So number 1 and number 2 both have that key word that I cannot stress enough. If you see equivalent, you type it into Desmos. So for number 1, you're going to take that initial expression that they give you, type that into Desmos, and then type in all 4 of your answer choices. In this case, answer choice B fit the graph perfectly. For number 2, it looks really gross, I know. Please be careful about using your parentheses. I don't want you to get that mixed up. But if you type that in and you start to type in your answer choices, you're going to find one that matches. If you don't see one at all, go back, check your parentheses, make sure you typed it in correctly. If you take more than a couple minutes on it, skip it and come back to it later. I don't want you stressing out over it and missing on other problems that you can do just because you typed in something wrong. Number 3, what's the value of x? If we see an equal sign, we cut it in half. Haven't really been writing this out that much, just for the sake of time, but I did for this one. So if you see that equal sign, cut it in half. The left-hand side gets set equal to y, and the right-hand side gets set equal to y. When you type that in, you're going to see where they intersect, and they intersect at 10, at x equals 10. Number 4, they give us a function in this table, so these are our x values, these are the y. And they want to know what the difference between the minimum value of this and the minimum value of this is. Well, they don't really care about what's going on in the x's, but they care about what's going on in the y's. We don't have much information to go off of, so we can only assume that these 5 numbers are true. The minimum value of this is going to be at -3. Again, we don't care about this, we're only worried about this column. So this one's at -3. And for this one, we actually had to graph. And that one ended up being at -19. So the minimum of the first one's at -3. Minimum of the second one is at -19. They want to know the difference between them. My first thought was -16, but remember, we're measuring the distance. And even if you travel back in time, you're not traveling a negative distance. So it'd be positive 16 units. Number 5, this one's really just vocabulary. It's really similar to a problem we did in the first review talking about the bacteria. But they want to know what situation could be modeled by this function. To begin with, we see that this is exponential, so we're talking about growth and decay. That first number, that 200, is going to be our initial population. Unfortunately, every answer choice has that, so we can't eliminate any just yet. But in the middle, we have 0.98. If it's less than 1, then it's decreasing. So we only have A and B left now, because C and D were increasing. Then it says they decrease by a rate of 2% per year. This one is a rate of 2. This question is really just picky more than anything, but if we're looking for rate, then we're looking for percentage. So because of that, 5 is answer choice A. Number 6 is an example of one that we just have to graph. The smallest 0. 0 is solution, x-intercept. Please let that be something that you remember. 0, x-intercept, and solution are all the same thing. So if you graph this, we have these 3 x-intercepts. If you're looking for the smallest, it's at -5. We have to look at number 7 and see that equal sign and know that we're going to split it apart and type it into Desmos. So you're going to take the left side, set it equal to y, take the right side, set it equal to y, and see where they intersect. When you graph it, they intersect at 6.5. Number 8, we're going to graph this, and we have to know what the value of the y-coordinate of the circle center is. Really, they're just asking you to find the center of the circle, which you can do by looking and then guessing and checking, and then tell them what that second part of the coordinate is. Number 9 is dealing with the graphs of polynomials, and we need to know a little something about multiplicity. So function f is given to us, and the most we need to do with this function is just graph it. function g, we have to actually construct. So it says that it has a root at 6, meaning that x equals 6. To work backwards and put it into an equation, I can subtract 6 on both sides, which ends up having x minus 6 over here, and it equals 0. Then it says a double root at -3, which means that we have x equals -3 with a multiplicity of 2. Multiplicity can be represented by an exponent. So I did the same thing to -3 that I did to +6. I just moved it over to where the x was. When I moved 3 over, I added it, so I got x plus 3. Multiplicity of 2 means that we have an exponent of 2. So I have x minus 6 and x plus 3 squared. So this is my function for g. It says that we have a leading coefficient of 1. We don't always have to write down 1, but I put it there just so you could see what we were doing. Now that we have both g and f functions, you need to graph them both. For f, we're looking for the relative minimum, so look for a low point. And for g, look for a relative maximum. I won't show the graphs, but for minimum, you're looking for a point down here. For maximum, you're looking for a point up here. So these are the two that I found. Now, they're not just asking for you to find that minimum and maximum. They're asking you to find the horizontal distance. Horizontal distance is a fancy way of saying tell the distance between the 2 points. So you could say 4 minus -3, or if you're a visual person like me and you want to see it on a number line, here's the horizontal distance between the 2 points. You end up going 7 places, so your answer would be 7. Number 10, you just have to graph the circle and then figure out what the radius is. So remember, to find the radius, you start at the middle of the circle and you're going to count out however far it takes you to get to the outside of the circle. Diameter is double the radius, so from one side to the other. So my radius is 4, which means my diameter was 8. We have our first function has a root at -6 and -2. And this graph has a root at -4 and at -2 and at 3. So they want to know what the distance between the two smallest x-intercepts are. This one's a little bit tricky, so you gotta be careful. We're looking for the x-intercepts. So remember, a root is the same thing as an x-intercept or solution or a 0. So our smallest root is -6. And if we look here, our smallest root is going to be at -4. So the distance between -6 and -4 is 2. And you might have said answer choice A, which is -2. But remember, we're measuring the distance, and distance can never be negative. That's why it's answer choice B. For number 12, this is another one that you can graph, or you can just look at it and know. This we did most recently, so I feel like this is probably the freshest thing on your brain. But to find the center of the circle, you take these coordinates here, and you flip them. So if that's +5, the x-coordinate's -5. And if that's -3, the x-coordinate is +3, which means the center of the circle is at -5, 3. But again, if you don't remember that, that's fine. If you graph this in Desmos, you can look at the circle and guess and check until you find the center. Number 13, equivalent. I cannot stress that enough. If you see equivalent, type it in exactly how you see it. Type in your answer choices and match the graphs until you find one that is identical. In this case, it was answer choice B. So number 14 says that the coverage area for a radio station can be modeled as a circle with the center at the station's transmitter, and this circle has a radius of 25 miles. The population density, so the number of people that live in each mile, is about 15.8 residents. So they want to know how many people reside within the circle of the station's coverage area. So the first thing we need to do is find the area of the circle. This is going to tell us the amount of space that we're working with. You need to remember the area of a circle is pi r squared, with r being the radius. It tells us the radius is 25, so I plug in 25 squared and got 625. I like my numbers to be pretty as long as possible, so I kept bringing down pi and left it how it was. If you want to go ahead and multiply that out, you'll get a number around 1,963. You don't have to, but regardless, we're going to end up with the same answer. So now that we have the area, we know that 15.8 people live in each mile. So to find the population density, we're going to multiply the area times 15.8. We got about 31,000 because it has us rounding to the nearest 100, not th. For number 15, we have to use a little bit of logic. So it says that a boat takes 30 minutes to travel 10 miles upstream. Now, since we're going upstream, we're fighting the current, so I know that the boat's going to be moving a little bit slower than it actually should be. So if we go 10 miles in half an hour, I can double this and say that in 1 hour, I'm going 20 miles. When you drive a car, you measure in miles per hour, not miles per half hour. So we know that my actual speed is somewhere around 20 miles an hour. But that's how fast I was going when I was actively fighting the current. So it slowed me down by 3 miles an hour because that was the speed of the current. So to get 20, I subtracted 3 from my actual speed. To find my actual speed, I need to take 20 and add those 3 miles an hour back onto my speed, which is how I got 23 miles an hour. So number 16 says that an experiment attempts to simulate temperatures in degrees Fahrenheit for the first 12 hours of the day. So they give us a piecewise function to model the progression at any time during the experiment. What's the maximum temperature simulated during the experiment? Now these kinds of questions are slam dunk. They are very, very easy. All you have to know is how to type in a piecewise function into Desmos. So remember that piecewise functions are like milk in your fridge. Canned goods are good for a long time, but milk expires after a certain period. So this first function, 48 plus 5x, expires if it's less than or equal to 0 or greater than 4. This last function, 81 minus 1x, expires if it's less than or equal to 7 or greater than 10. And of course, the middle function also has its own parameters. So genuinely, all you've got to know how to do is type this in. So we'll go to Desmos, and you're going to type this in 3 separate lines. So the first function I have highlighted in blue will go in like this, but this line goes on forever and ever in both directions. Now it's a canned good. It doesn't really expire. To turn it into milk, you're going to use a curly bracket. It should be on your computer's keyboard, but if you can't find it, if you go, oh my goodness, I don't know what this is. That's crazy. If you go on your Desmos keyboard and hit ABC, should be that bottom button right there to get your curly bracket. In your curly bracket, this is where you're going to put your expiration date or your parameter. So it's 0, less than x, less than or equal to 4. Now it expires. So I'm going to put in my second jug of milk that I have highlighted in red. 60 plus 2x, it goes on forever. I'm going to make it expire. And now it's kind of connecting to each other. So my last function that I've highlighted in green, put on my expiration date here. And that's it, I've graphed it. So it wants to know the maximum temperature, and temperature is going to be my y value. So I go to my graph, my highest y value is at 74. So my answer would be B. Number 17 has a missing value of h and is asking for what value of h will make the equation true as long as x does not equal -1. Now that x does not equal -1 is mainly for if you are solving it by hand. It's important for you to know that, but with the way we're going to solve it, all you need to do is take the left side, set it equal to y, put it in Desmos, and do the same thing for the right side. Now, when you type this in and you put in h, it's going to automatically think that you are trying to make a slider out of h. I want you to click yes, because you'll be able to slide values for h and play around with it until you can make it match directly to this graph. So really, you are solving this the same way you would with just a straight up equal sign, but since we have that missing variable, you have to play with a slider to make it match directly. After playing with it, I found that when h was 5, the graphs matched perfectly. So number 18 is kind of a lot to look at. So it says that a farmer is enclosing a rectangular garden using one side of his barn. So here's his barn, it's already here. The garden shares a wall with the barn, so he only needs fencing for 2 of the widths and 1 of the lengths. So he has 92 meters of fencing already. It says that the length will be longer than the width, and they want to know what the width would be. So to find this, we need to use both the perimeter and the area. We know that perimeter is normally all of the sides added together, but since we're missing one of the lengths, we're only adding together length, width, and width. So I wanted to make it easier on myself and convert length and width to letters. So I changed length to y and width to x. Well, since I have 2 widths, I said 2x, and it told me that the perimeter was 92 because he had 92 meters of fencing total. I'm also going to end up using the area. An area is always length times width, which in this case would be x times y. So I'm going to plug in my perimeter into the area. And in order to do that, I have to get the perimeter to be solved for y. So I'm going to take the perimeter that we figured out, and I'm going to get y by itself by subtracting 2x from both sides. When I do that, I get this function right here. So now I can take it and plug it into y for the area. So my area equals x as my width times, this is currently my length. So I took x and I distributed it to both terms, and I got this as my area. So now that I have my area, I'm going to graph this and I'm going to find the maximum point on the graph. Remember, maximum looks like a mountain and it's the highest point. This is the coordinate at the very top. My y value tells me what the area is, so the biggest area that we could possibly have. My x value tells me that missing width. So my missing width is 23. Number 19 says that Georgia is a member of the debate team. She's won 75% of her first 32 games this year. We need to know how many games in a row she needs to win to have a winning percentage of exactly 80%. So first we need to know how many games she's actually won. So 75% of the 32 games she's played is 24. So currently she has won 24 out of 32 games, and we know that equals 0.75. So if she keeps playing games, she's adding games to the 32. So if she plays one more game, she's played 33, right? That's where the plus X comes from. And it says that the game she's playing in a row, she's winning. So I can also add that game she played to the top because I'm assuming she's winning. So if she plays one more game, then she's now won 25 out of 33. So my X's just represent the games that have been played in a row. And we're going to keep adding games until we get that winning percentage up to 80%. And if you have a percentage, you're going to start at the back and you have 2 butt cheeks. So you go over 2 butt cheeks. So now that we have this equation, you're going to split it in half with the equal sign. Set that equal to y. And then you're going to set the left side equal to y. And you're going to find their point of intersection. In this case, they intersected at 8. So the answer is 8. She needs to play 8 more games to get a winning percentage of 80%. So number 20 is talking about mass. And if you're like me, I freaked out a little bit when I first read this problem because I never took physics. I don't know much about mass, but it's a lot easier than it seems. So it tells us that we're using a rectangular prism, and it gives us the dimensions of this prism. So we're going to start by finding the volume. Remember, volume is the measurement of the inside, so how much water it can hold or whatever other liquid. So my volume for a rectangular prism is the area of the base times the height. Well, for a rectangular prism, the base is a rectangle, and I know area of a rectangle is length times width. So my actual volume formula is length times width times height, which is what I wrote out here. So multiplying that out, I know that my volume is 150 cubic centimeters. Mass is just weight. So it's the volume, so essentially how much water it can hold, times the density, which is the weight of each cubic centimeter. So all you're doing is taking the volume and multiplying it by how much each of those cubic centimeters weigh. So you've got 150 for the volume times 7.9 for the density, and your mass is 1,185 grams. Number 21 is asking for a discontinuity. So a discontinuity is something weird. It can be a hole where a missing value should be. It can be an invisible line that the graph seems to bounce off of. It could be where a graph goes on for infinity. It could be a lot of different things. So in this graph, where x is 5, it looks something like this. That's part of the graph, and here's another part, and they both go off in different directions forever. And x equals 5 ends up being right here. Well, it looks like the graph is bouncing off of that invisible line that's happening right here. And when we have an invisible line, it means that we have an asymptote. Up and down would be vertical, so your answer is B. I'm not going to lie, 22 is a little bit of work. It's not hard, it's just not very quick. So it's asking about the rate of change. So they give us specific values. So we're using where x is 5 through x is 8. Everything else I do not care about. I scribbled it out because those extra numbers stress me out and I don't want to see it if I don't need it. So rate of change would be taking your last value and subtracting your smallest value from it. So that's what I did here, and I got about 18. And we're finding the average. So we have 4 values, so I divided it by 4. So their question is, they gave us these 4 different functions, and they're asking which one of these functions has a very similar rate of change at the same values. So what we have to do is graph every single answer choice, turn the functions into tables, and find the rate of change from 5 to 8 for each answer choice. To save some time, I went ahead and found those rates of change here. And the only one that was remotely even close was answer choice C. Number 23, we have 2 functions. Function H is this graph. Function G is this function, but we don't see the graph. So they're asking about maximum values and about a smaller value where x is 1. So looking at function H, it looks like the maximum value is where y is 5, and where x is 1, it looks like that maximum value is about 4.5. When you go to Desmos and you graph this, it kind of looks something like this, where the maximum value is where y is 17. And if you go to find where x is 1, y is about 13. So what it looks like is that both of the values for G are greater than the values for H. So answer choice C says that H has a smaller maximum value and it has a smaller value at x is 1. This little table is honestly unnecessary, but in case you were confused about what I was talking about, I wanted you to see a table of values so that you can compare. G clearly has the bigger values, so that's why our answer is that H is smaller. Number 24 is another type it in Desmos situation. So this is a circle, and you're going to take that whole thing and type it in, including the part that says equal to -20. Do not split this in half. So you need to analyze the circle in Desmos and guesstimate where the center is and what the radius is. So on my end, it looks like the center was about -4.5 and 2.5. And from there, I guesstimated when counting out for the radius, and it looks like it's about 2.5. You can't be exactly precise, but having multiple answer choices helps. Number 25 isn't as complex as it seems. So it says that this is a track, and the track has 6 lanes that are 1.6 meters wide apiece. Everything else is already measured in meters, so we don't have to do any kind of unit conversion, which is a pain in the tail. So if there are 6 lanes and each one is 1.6 meters wide, I multiplied these together and got 9.6. So the white part might be that 36.5 meters, but this extra piece on the outside is 9.6 meters wide. So to get the true radius of these 2 half circles, I have to actually add this together, and that gave me about 46.1. This here is still included in that radius. So I don't have to add 9.6 anywhere else. This is the width, and the width remains unaffected because it runs parallel to the track. It doesn't intersect it. So it wants to know the perimeter of the outside of the track, not the area. So the perimeter of a circle is also the circumference. So we needed half of the circumference for this, half of the circumference for that, and then 2 of these widths added together. So this is the perimeter that I'm looking for. That's what I wrote down here. Hopefully this isn't too confusing. I was hoping to kind of sketch it out for you so you could see. So we need to have 2 of the widths, which is at 84.4, write that here, plus I can't find the circumference of the whole circle, so I need the circumference of half the circle. That's what this is. Same thing on the right side. I need the half circle for the right side. Now, when I work this out by myself, I just go ahead and combine these two half circles. I know that they have the same measurements, but for the sake of this little equation that I wrote out, I figured it'd be best to see it like this. Now I know that the radius is 46.1 and circumference of a circle is 2 pi times the radius. So here I just plugged in my values and I kept working my way down until I got down to this value here. It says to round to the nearest tenth of a meter, so I got 458.5 meters. For number 26, we're back to talking about discontinuities. Remember, discontinuities are something weird on the graph. So this graph has two discontinuities. It has a hole where there is a missing value, and then it has a vertical asymptote. That's what I sketched out here. The reason why the answer is where the vertical asymptote is because it specifically says positive x value. The hole is at x equals -3. If you're not super comfortable with looking at the graph to find discontinuities, you can always do this by hand, which isn't that bad. You can factor the function. X plus 3 stays on top, and that bottom trinomial factors into x plus 3. Oops. And what ends up happening is that the top and bottom can cancel out. And when you can cancel out values like this, it turns into a hole. Anything left on the bottom turns into a vertical asymptote. So that's always an option, but in a pinch, I always prefer to look at the graph.